Harvard scientist Avi Loeb believes the discovery of interstellar objects might be proof that we're not alone.
The unsettling revelation, are we truly alone? From the moment Avi Loeb stepped into view, the atmosphere shifted at the prestigious halls of Harvard University. Where astrophysicists traditionally speak in measured terms, Loeb delivered a statement that sounded almost unhinged. The discovery of interstellar objects might not just hint at alien life. They might already be proof that we are not alone. His voice, firm and direct, emphasized one startling possibility: the frozen worlds in our own solar system, symbolized here by Pluto, may not be the barren, desolate bodies we assumed. Beneath its distant, icy surface could lie evidence of ancient alien cities long buried in silence. Imagine that, an entire civilization, or traces of one, hidden beneath a cold, remote dwarf planet at the edge of our sun's reach. To many seasoned scientists, such a proposition seemed almost sacrilegious. It called into question the basic assumptions of planetary science, astrobiology, and the extent of human hubris. And yet, Loeb wasn't speaking in hyperbole. He was offering a challenge. Look again. Think bigger. A civilization might once have thrived on a planet we barely understand. The story begins with what we might call cosmic echoes. For decades, humanity has pointed its best instruments outward: telescopes, radio dishes, probes. We've scanned the skies for a whisper, a signal, a flicker, a visitor. In 2017, the interstellar object known as Oumuamua entered our solar system at astonishing speed. Its shape and trajectory defied natural expectations. While many regarded it as a bizarre comet or asteroid, others, including Loeb, argued its behavior matched that of an engineered object. The CBS News com. If even one interstellar probe from another civilization passed through our realm, and if we recognized it for what it was. But here's the twist: the search for alien technology isn't just about far-away stars and distant worlds. Some of the most compelling clues may lie in our own backyard. When the spacecraft New Horizons swooped past Pluto in 2015, it revealed a world far more complex than anticipated. Vast nitrogen glaciers flowed, towering methane ice cliffs rose, cracks deeper than Earth's Grand Canyon cut across the surface, and hidden beneath the crust appeared to be a subsurface ocean. Apparent geological activity, internal heat sources, and manganese of material exchange, all the ingredients for something more than just a frozen rock. Scientists label these as necessary conditions for life. But Loeb asked a different question: could they also preserve remnants of past life or even civilization? The terrain of Pluto is seductively alien, not simply lifeless but active. Frozen, yes, but dynamic. The surfaces captured by New Horizons show that Pluto isn't a dead world. It's a world quietly shaping itself. If you accept that life doesn't necessarily need sunshine, just energy and chemistry, then worlds like Pluto suddenly become contenders. And if life once existed, could a remnant survive under the ice? Could structures, cities, domes, or even ruins linger beneath? Loeb's hypothesis takes this further. Artificial illumination, the concept that a planet or moon might betray its intelligence not via radio signals, but via city lights. Astronomers scanning exoplanets consider whether a civilization on a distant world might create enough light to be seen, even when the star's light dominates. That same logic can apply locally. The outer solar system is full of dim, icy worlds. If any of them host structures or powered sources of light, their surfaces would reflect in ways that nature alone doesn't easily produce. Straight lines, geometric patterns, localized light sources. If you know what you're looking for, you might see something unexpected. Loeb and his colleague Ed Turner ran calculations: a city the size of Tokyo, if illuminated with sufficient brightness, could in principle be detectable at the distance of the Kuiper Belt. That's provocative. It means we may already have the tools to test such hypotheses, right in our cosmic backyard. If we apply that idea to Pluto, or its moon Charon or other Kuiper belt bodies, the challenge becomes one of precision, teasing out faint glows, filtering out natural light, auroras, solar reflections, and distant galaxies. The key here is not blind speculation. It is disciplined investigation at the edge of our observational capability. Loeb emphasizes that the techniques are at their limits. Any candidate signal must satisfy multiple tests: spectral signature, variability, geometric consistency, elimination of known natural sources. The reason the hunt is compelling is that nature rarely gives clear lines of geometry, regular flickers, or perfectly straight patterns in frozen chaos. When you see something that just fits, you pay attention. By now you may ask, if there is any chance of catching a city light or a stray artifact, where should we look? Loeb's answer: the outer solar system. Pluto, the Kuiper belt, the moons, the dwarf planets. These frozen worlds sit quietly on a cosmic stage, often unperturbed by the intense heat and tectonics that erase ancient features elsewhere. If a civilization ever existed in our system, these silent bodies might still preserve relics that warmer planets would have long erased. Consider the following scenario. Beneath kilometers of ice on Pluto lies a cavern. Within that cavern, ancient domes, city grids, tunnels. Once lived a civilization that vanished eons ago. The surface above is frozen and dark, but a technology survives, perhaps low-level artificial light, or materials reflecting in odd ways. From a distance, one might detect subtle periodic variations in brightness as Pluto rotates. One might see a dark patch that glows slightly more than ambient ice. One might identify a geometric reflection pattern inconsistent with natural glacial flow. All of this remains speculative, yes, but that is the tension we must explore. Because when you combine compelling clues, interstellar objects behaving oddly, distant icy worlds showing geological activity, the logic of detectable city lights, the story becomes not just science fiction, but a carefully reasoned argument we may be overlooking ancient tech hidden in plain sight, within our reach. In short, the unsettling revelation is that our assumptions about life, about ancient civilizations, about where they might hide, are far too narrow. The possibility that Pluto may not be lifeless, as Loeb suggests, should not be dismissed purely because it challenges comfort. We should instead broaden our gaze. The search for life is no longer only about microbial biology on warm planets. It is also about relics of civilizations, evidence of intelligence, shadows of the past. And if one of the best places to look is our own solar system, then we owe ourselves the investigation. By asking these hard questions, by positing that Pluto could host ancient alien ruins or cities beneath the ice, Loeb invites us to reconsider our place, our history, and our expectations. The universe may hold far more surprises than we are comfortable with, and the next grand discovery might be waiting in the darkness of the Kuiper belt, rather than the vast emptiness of distant galaxies. The hunt for light in the dark, searching for signs of ancient civilizations, the universe, in its vastness, is a symphony of light and shadow, of energy and silence. And in that silence, astronomers have long hoped to hear a signal of intelligence. But as A.V. Loeb's radical hypothesis suggests, the signals may not always come in sound waves or radio frequencies. Sometimes they come as something subtler, something almost imperceptible: light. Not the light of stars, but the glow of technology. Evidence of civilizations that once existed or still exist. And if anyone has dared to look for it, Loeb and his collaborators have. Long before the idea of alien cities on Pluto reached the public imagination, researchers were already scanning the skies for unnatural illumination. The principle is deceptively simple. On a cosmic scale, intelligent beings need energy. They manipulate their environment. They create structures that interact with light. If a civilization covers a planet with illumination, that planet could betray itself even across interstellar distances. Astronomers call it technosignature detection. On exoplanets, the idea is applied by observing light curves. the faint dip or rise in brightness as a planet passes in front of its star. Natural planetary surfaces produce predictable changes, but structures or lights arranged by an intelligent agent could produce anomalous patterns. Loeb's insight was to take this method and apply it closer to home. Our solar system, he reasoned, might already host worlds with preserved remnants of intelligent activity. Far from the sun's warmth and the tectonic churn of larger planets, bodies like Pluto are essentially cosmic time capsules. Over billions of years, surface processes on Earth would erase traces of cities' machinery or other artifacts. Ice, dust, and volcanic activity relentlessly reshape a planet. But on a frozen, distant world, the ice can act as a preservative. The cold is not death, it is stasis, a slow-motion archive. When New Horizons sent back images of Pluto in 2015, scientists were struck by the planet's complexity. Far from a barren rock, Pluto displayed vast nitrogen glaciers that flowed like frozen rivers, towering methane ice cliffs, and cracks deep enough to dwarf Earth's Grand Canyon. Beneath the surface, hints of a hidden ocean suggested heat sources and material movement. These are not just aesthetic curiosities. They indicate energy movement and chemical processes, all essential ingredients for life. But Loeb encouraged looking at these processes through a different lens. What if some of these features are not purely geological? What if, embedded within ice flows, frozen plains, or hidden caverns, lie the faint fingerprints of a vanished intelligence? The search for artificial light, however, is not easy. Space is an orchestra of natural noise. Aurora shimmer, sunlight reflects off ice, cosmic radiation produces sporadic flashes, and even distant galaxies can fool instruments. Disentangling artificial signals from natural phenomena requires precision instruments and patience. Researchers must account for spectral signatures. Does the light show a chemical composition inconsistent with natural processes? Variability. Does it blink or flicker in an organized manner rather than randomly? And geometric consistency. Does it form straight lines, repeating patterns, or shapes that nature rarely produces? Only when a signal passes all these checks can it be taken seriously. Loeb's calculations with Ed Turner showed something remarkable. A city the size of Tokyo, if adequately powered, could be detectable even at the distance of the Kuiper Belt. To some, this seems fantastical. How could a city glow faintly enough to be subtle, yet consistently enough to be detectable across billions of kilometers? But it is not impossible. Technology leaves traces. Energy usage produces heat. Reflective materials interact with sunlight in ways that betray structure. And while modern telescopes can barely resolve surface features on Pluto, they can detect brightness variations consistent with unusual activity. With high-resolution photometry and repeated observation, researchers can map these variations, searching for anomalies. But why would ancient civilizations leave such detectable traces? Here, imagination meets logic. Suppose a civilization once reached technological maturity within our solar system. Perhaps they colonized a distant, icy planet like Pluto. Their presence would have required energy, infrastructure, and habitability. Even if temporary. Buildings, roads, domes, machinery, and lights. All of these could leave enduring signals. Unlike on Earth, where erosion, earthquakes, and human development erase evidence over millennia, Pluto's frozen environment might preserve these signals for billions of years. Ice becomes a cosmic vault, protecting the past. The methodology of searching for light is multifaceted. Some researchers focus on heat signatures, localized areas that emit more infrared energy than surrounding terrain in ways inconsistent with geology. Others examine reflected sunlight, looking for patterns that defy random scattering. Even subtle changes in light curves during rotation can reveal artificial geometry, a pattern repeated across multiple observations. Consistent angles, repeated reflections, or brightness variations aligned with the planet's rotation could indicate intentionality. The challenge lies in scale. Even faint structures produce minimal signals against the glare of the sun and the complexity of surface ice. But technology is advancing. Next-generation telescopes, orbiters, and imaging satellites offer resolution and sensitivity previously unattainable. The tools exist to explore these subtle cues. Beyond Pluto, the concept scales. Moons like Charon, Eris, and Makemake are candidates. They share Pluto's preservation, friendly environment, cold, geologically quiet, and distant from solar interference. These worlds might harbor relics even more pristine than Pluto itself. But the search also invites humility. A positive detection requires extraordinary evidence. Researchers must confirm that no natural process, volcanism, ice flow, auroras, or cosmic interactions can explain the observed anomaly. Only after eliminating all plausible natural explanations does the possibility of intelligent origin remain. The hunt for artificial light is, in a sense, a hunt for history. It is not solely about finding living civilizations, it is about detecting relics of the past. What if a city, abandoned millions of years ago, still interacts with its environment in detectable ways? What if frozen domes or structures, partially exposed, reflect sunlight with precision? What if residual energy, stored in superconducting or exotic materials, produces faint, persistent illumination? Each subtle flicker becomes a potential clue. The implications extend beyond mere discovery. Detecting ancient alien artifacts within our solar system would redefine human understanding of history. It would challenge the notion of Earth as the cradle of intelligence, expand the definition of habitability, and force a reevaluation of technological evolution. It would suggest that the universe is not just vast, but populated with civilizations that rise, fall, and leave lasting marks. Even if these civilizations are long gone, their remnants would testify to the possibility that intelligence is not unique, and that the cosmos has stories older than our species. Loeb's approach combines rigorous science with daring imagination. He does not claim certainty, but he frames questions in a testable way. Observations can be made, hypotheses falsified, and patterns analyzed. The search for artificial illumination in the Kuiper Belt exemplifies how forward-looking science navigates uncertainty. It acknowledges the limits of current instruments while pushing their capabilities to the extreme. In doing so, it exemplifies the intersection of curiosity and discipline that drives all great discoveries. Consider the broader context. Across the Milky Way, astronomers have already scanned thousands of exoplanets for signs of unnatural energy. Dyson structures, massive orbiting energy collectors, and anomalous stellar dimming patterns are under scrutiny. Some signals, like KIC 8462-852 Tabby's starred, have challenged conventional astrophysics, sparking debates about natural versus artificial origins. The methods developed for exoplanets translate naturally to our local solar system, where signals would be fainter, yes, but also more accessible to repeated observation. The advantage of nearby exploration is temporal immediacy. Missions can be launched, instruments can orbit, landers can probe, something impossible for stars hundreds of light years away. This local focus is vital. While interstellar phenomena are exciting and dramatic, they cannot be explored directly in real time. Signals from distant stars arrive delayed by decades or millennia. Nearby planets and moons, however, allow iterative study, repeated measurements, close-range imaging, spectral analysis, and eventual in situ investigation. It is here that ancient technology, if it exists, could be revealed. And as Loeb emphasizes, Pluto stands out. Its geological stability, icy preservation, and complex surface features create conditions ideal for hiding, but also potentially revealing traces of past civilizations. Thus, the hunt for light in the darkness becomes more than a speculative exercise. It becomes a disciplined program of observation, hypothesis, and validation. Each data point is scrutinized, each anomaly cataloged, each potential signal cross-checked against natural explanations. And yet, even in failure, there is progress. Understanding the limits of detectability refining instrumentation, and testing new methods all advance science. The very act of looking forces humanity to think bigger, imagine differently, and consider possibilities beyond conventional paradigms. In essence, this cosmic exploration is a testament to curiosity itself. It is about training our instruments and minds to look for evidence of intelligence where none was expected. It is about recognizing that our solar system may contain secrets that challenge human arrogance, ancient civilizations frozen in ice, subtle lights hinting at lost technology, and remnants waiting for someone bold enough to notice. The search is difficult, precise, and uncertain, but therein lies its beauty. Avi Loeb's vision, daring yet methodical, is a call to expand what we accept as possible. Pluto, once dismissed as a distant, icy rock, becomes a laboratory of imagination grounded in scientific rigor. Artificial illumination, geometric patterns in ice, preserved subsurface structures, all are hypotheses waiting for confirmation. Each faint flicker of light in the outer solar system may carry a message billions of years old, a whisper from a civilization that existed long before humans ever gazed at the stars. And so, the hunt continues. Telescopes track brightness variations. Algorithms filter cosmic noise. Teams analyze every photon, every reflection, every irregularity. The outer solar system transforms from a silent void into a potential archive, a repository of ancient intelligence waiting to be rediscovered. The cosmos may indeed be full of life, full of history, full of signals just beyond the reach of casual observation. The question is no longer whether intelligent life exists somewhere, but whether it has left traces here, in the frozen outskirts of our own backyard. The implications. Humanity on the threshold of cosmic discovery. If the first 2 points of this investigation compel us to look deeper into Pluto, the Kuiper Belt, and the outer solar system, then point 3 asks a far more profound question. What happens if we find something? The implications of detecting evidence of ancient alien civilizations in our own cosmic backyard would ripple through every facet of human understanding. Science, philosophy, religion, and society itself. Avi Loeb's hypothesis is not just an invitation to explore. It is a challenge to reconsider our place in the universe, the uniqueness of human intelligence, and the fragility of our historical assumptions. The first consequence is scientific. Imagine a scenario in which high-resolution telescopes detect a pattern on Pluto that cannot be explained by natural processes. Perhaps a subtle, repeating glow beneath the frozen surface, or geometric reflections that appear too precise for glacial flow. Scientists would face a verification process of unparalleled rigor. Spectroscopy would analyze the chemical composition of the reflected light. Variability would be observed across rotational cycles. Cross-validation using multiple instruments and missions would aim to rule out atmospheric anomalies, auroral activity, cosmic rays, and distant starlight contamination. Yet, if all natural explanations fail, we would confront evidence of artificiality. Traces of intelligence billions of years old. This discovery would force a reassessment of our understanding of planetary history. Pluto, previously considered a minor icy world on the outskirts of the solar system, would emerge as a key archive of ancient intelligence. Researchers would ask, what technology was used? How did it survive in a cold, geologically stable environment? What does this tell us about the potential for life in extreme conditions elsewhere? Even if the civilization never reached technological sophistication comparable to Earth, the presence of structured artifacts, buried cities, or energy emissions would prove that intelligence is not unique to our planet. The scientific paradigm, long based on the assumption that Earth represents a rare cradle of life, would be appended. Beyond science, the philosophical ramifications are staggering. Humanity has long grappled with the question, are we alone? The existence of intelligent life elsewhere, especially evidence preserved within our solar system, transforms that question from speculation into empirical reality. Scholars and philosophers would debate the meaning of such a discovery. Would it shift the human perspective from anthropocentrism to a cosmic consciousness? Would the realization that civilizations can rise and vanish long before our species existed prompt reflection on our own mortality and the sustainability of intelligence? Loeb's hypothesis pushes us to confront a humbling possibility. Even advanced civilizations may disappear, leaving only subtle traces behind, preserved in frozen silence. Religious and cultural implications would follow. Many belief systems situate humanity at the center of creation. Evidence of ancient intelligence outside Earth challenges those narratives, not necessarily to negate them, but to broaden interpretation. The realization that sentient beings once existed, or perhaps still exist, in the outer solar system could provoke theological reflection on life, purpose, and divine creativity. Societies may struggle to integrate this knowledge with long-held doctrines, potentially inspiring new philosophies or even reconfiguring ethical frameworks. How do humans relate to intelligence that predates their own existence by millions or billions of years? Such questions would reverberate through academia, culture, and everyday life. The technological consequences would also be profound. The very process of detecting subtle artificial light, analyzing minute variations in reflection, and distinguishing patterns from noise pushes observational techniques to their limits. If artificial signals are discovered, it would validate decades of research into high-precision photometry, infrared spectroscopy, and space-based imaging. It might prompt a wave of innovation, inspiring new telescopes, orbiters, and probes specifically designed to investigate the Kuiper Belt and beyond. Engineering would evolve not just for exploration, but for preservation, analysis, and even possible interaction with preserved artifacts. Humanity would be thrust into a new era of cosmic archaeology, where spacecraft are tasked not merely with surveying, but excavating, imaging, and understanding the remnants of alien civilizations. There is also the broader societal impact. A confirmed discovery of ancient intelligence in our solar system would capture the imagination of billions. Science fiction, once dismissed as fantasy, would gain a grounding in reality. Media, literature, and art would explode with interpretations of civilizations long gone, frozen under ice, their cities reflected in faint glows visible across millions of kilometers. The public's relationship to space exploration would shift dramatically. Funding for missions beyond Earth, long challenged by economic and political constraints, could skyrocket. Humanity might prioritize exploration of previously neglected regions. The Kuiper Belt, Pluto, Triton, and other distant icy worlds, as the potential repositories of ancient knowledge. Yet, alongside excitement comes caution. Loeb's hypothesis also warns of the fragility of interpretation.